Scene script. Have you ever wondered how Saturn's rings were formed? It's a question that's been boggling the minds of astronomers for centuries. Today we delve into the enigma of these cosmic bracelets that make Saturn such a distinctive spectacle in our solar system. Saturn's rings, when viewed from a distance, appear as solid, shimmering hoops encircling the gas giant. But don't let this illusion fool you. In reality, these rings are a bustling metropolis of ice particles, with a smattering of rocky debris and dust. These countless tiny particles, each in its own orbit around Saturn, collectively create the stunning visual phenomenon we associate with the sixth planet from the Sun. Now you might be wondering, why ice? Why not some other material? Well, the answer lies in the origins of our solar system. When the planets formed, they were encased in a swirling disk of gas and dust. The outer regions of this disk, where Saturn resides, were cold enough for water to freeze. Over time, these ice particles, along with bits of rock and dust, coalesced to form Saturn and its iconic rings. But here's a fun fact. While the rings seem dense, they're actually quite thin compared to their overall size. Picture this: if you were to scale the rings down to the size of a football field, their thickness would be less than the width of a razor blade. It's this delicate balance between size and density that gives the rings their ethereal, ghost-like appearance. So, what's the story behind these icy, orbiting particles? How did they come to form these vast, majestic rings around Saturn? And why does Saturn, out of all the planets in our solar system, have such pronounced rings? The answers to these questions take us on a journey back in time, to the early days of our solar system, and involve a fascinating interplay of physics, chemistry, and celestial mechanics. So what could possibly lead to the formation of these fascinating celestial structures? Buckle up and prepare for a cosmic journey. To understand the formation of Saturn's rings, we first need to understand the birth of Saturn itself. So let's take a journey back in time to around 4.5 billion years ago. It was a time when our solar system was in its infancy, a swirling mass of gas and dust. Amidst this cosmic chaos, Saturn began to take shape. The birth of Saturn, like other gas giants, is believed to have started with a process known as accretion. Think of accretion as the ultimate cosmic recycling program. Gas and dust particles floating around in space start to come together, slowly building up mass over time. In Saturn's case, this process began with a core of rock and ice. This core acted like a cosmic magnet, attracting more and more material from the surrounding gas and dust. As the core grew larger, its gravitational pull became stronger, drawing in even more matter. Over time, this core became so massive that it could hold on to the lighter gases like hydrogen and helium, which make up the majority of Saturn's atmosphere today. Now you might be wondering, why didn't this process just continue indefinitely? Why didn't Saturn keep growing until it became a star? Well, that's because the surrounding material eventually started to run out. You see, Saturn wasn't the only one growing. Other planets were forming too, and they were all competing for the same resources. As a result, Saturn eventually hit a sort of growth limit, a point where it couldn't accumulate any more mass. So there you have it, the birth of Saturn, a process that took millions of years and involved billions of tons of cosmic material. A rock and ice core slowly growing, attracting more and more material, until it became the gas giant we know today. With Saturn in place, we've set the stage for the birth of its iconic rings. So Saturn is born, but how do we go from a planet to a planet with rings? This enigma has perplexed scientists for centuries, sparking numerous theories about the formation of Saturn's iconic rings. Among these theories, one stands out as the most widely accepted: the remnants of a moon. That's right, the stunning rings we admire today could be the celestial remnants of a moon that was brutally torn apart by Saturn's immense gravitational forces. Imagine a moon venturing too close to the planet, falling within its Roche limit. The Roche limit, for those who might not know, is essentially the point of no return. It's a boundary of gravity. Cross it, and you're at the mercy of the celestial body's overwhelming gravitational pull. Now picture this moon, drawn in by Saturn's gravity, crossing the Roche limit. As it gets closer to the planet, the gravitational pull becomes stronger on the side of the moon closest to Saturn. This difference in gravitational tug, known as tidal forces, begin to stretch and deform the moon, pulling it apart. As the moon disintegrates, it doesn't simply vanish into the void of space. Instead, its fragments begin to orbit Saturn, trapped by the planet's gravitational field. Over time, these fragments spread out and form a ring around the planet. The result? A magnificent celestial halo, a testament to the moon that once was. This theory explains why Saturn's rings are composed primarily of ice. The moon that was torn apart was likely an icy body, and its remnants now make up the stunning icy rings that characterize Saturn. Now, it's important to remember that this is just one theory among many. The universe is a vast, complex, and often unpredictable place, and there's always more to learn and discover. The destruction of a moon may sound dramatic, but it's just another day in the life of our cosmic neighborhood. So, we have a ring system in place, but it doesn't stop there. The story of Saturn's rings is one of constant change and evolution. Over millions of years, these majestic rings have been shaped and reshaped by the forces of nature. Gravitational interactions play a significant role in the evolution of these rings. Within the rings themselves, particles are constantly colliding, merging, and breaking apart. These interactions, although seemingly small in isolation, have a cumulative effect that contributes to the overall shape and structure of the rings. But it's not just the ring's particles that are at work here. The gravitational tug of Saturn and its moons also play a part. Saturn's powerful gravity pulls at the rings, helping to maintain their thin, flat shape. The planet's many moons, on the other hand, can have a disruptive influence. They stir up the rings through a process known as resonance, creating gaps and waves in the rings and contributing to their complex structure. New material is constantly being added to the rings as well. Micrometeoroid bombardment, a fancy term for space dust collisions, regularly deposits tiny particles into the rings. Additionally, Saturn's icy moons occasionally spew out gas and dust in a process known as outgassing. This ejected material can then be captured by Saturn's gravity and incorporated into the rings. Over time, these processes have shaped Saturn's rings into the glorious spectacle we see today. But the work isn't done. These rings are not static, they are dynamic and ever-changing. As we speak, collisions are happening, moons are stirring up the system, micrometeoroids are depositing new material, and outgassing is replenishing the rings with fresh particles. Even today, Saturn's rings continue to change and evolve just like our understanding of them. Our knowledge of these rings has come a long way, but there's still much to learn about these mysterious and beautiful structures that adorn the second largest planet in our solar system. The rings of Saturn, it seems, will always have more stories to tell. So, let's recap our cosmic journey. We began our voyage with the enigma of Saturn's rings, those stunning bands of ice and rock that have captivated astronomers and space enthusiasts for centuries. The rings' majesty and mystery are a testament to the infinite beauty and complexity of our universe. From there, we transported ourselves back in time to witness the birth of Saturn. This gas giant, the second largest planet in our solar system, formed over 4.5 billion years ago from the same nebula that birthed our Sun and the rest of our solar system. The planet's formation set the stage for the creation of its iconic rings. Our journey then led us to the violent destruction of a moon. This catastrophic event, likely caused by a collision with a comet or asteroid, resulted in a vast cloud of debris. This debris, held in place by Saturn's gravitational pull, eventually coalesced into the planet's rings. We delved into the ongoing evolution of the rings, a process driven by gravitational interactions and the steady addition of new material. The rings we see today are not static, they're dynamic and ever-changing, a swirling dance of ice and rock particles, shaped by the forces of gravity and time. It's these forces, the same ones that have shaped our own planet and the entire universe, that have given us the breathtaking spectacle of Saturn's rings. They remind us that even in the vastness of space, there are processes at work that can create something as intricate and beautiful as these shimmering bands of ice and rock. Saturn's rings, a beautiful testament to the dynamic and ever-changing nature of our universe. Until next time, keep looking up and wondering,